All right, so I bet you've got like a ton of articles on large language models just, sitting around in that LLM Basics PDF. Oh man, that thing looks intense, but don't worry. That's why we're here in this deep dive. We're gonna like unpack these LLMs and figure out, what they actually are and how they're already like, changing things up in the world around us. So, are you ready to become like an LLM pro?
Thank you when you are.
Okay, awesome. So, first
Yeah.
things first, what exactly are these LLMs anyway? I mean, they sound way more complex than just like your regular spell checker.
Yeah, you're right. They are. Chapter 1 of the guide describes them as like these complex neural networks. But the main thing to remember is that they can like understand and generate human language like way beyond just predicting the next word in a sentence. These LLMs can process information, learn from data, and even create different types of creative text formats, like poems, code scripts, musical pieces, email letters, like all sorts of stuff.
Okay, wow. That's pretty impressive.
Hmm.
But this guide is massive. It's got chapters on like everything, even ethics. Who knew language could be so complicated?
It's true. And it's a field that's like evolved super fast.
Yeah.
Chapter 3 talks about this shift from like basic statistical models to something called the transformer architecture, which was like a total game changer.
Transformers. Like those robots that turn into cars. Are we talking about AI that transforms into a truck or something?
Uh-huh. Not exactly, although
Yeah.
that would be pretty cool. But in the world of LLMs, transformer refers to a specific type of neural network architecture. It basically changed how we process language data and made the powerful LLMs we have today possible.
Okay, got it. So no shape-shifting robots for now, at least.
Yeah.
But you mentioned powerful, and I noticed that the guide doesn't just talk about the tech itself. It highlights how LLMs are actually impacting the real world,
Yeah.
not just in some Silicon Valley lab.
Exactly. Chapters 4, 2, and 7 give examples of LLMs being used in healthcare law, education, finance, like pretty much everywhere. It's not just a tech thing anymore. It's changing how we diagnose diseases, analyze legal documents, even personalize learning experiences.
Whoa, hold on. It can diagnose diseases. So is this like replacing doctors now? I'm picturing an LLM with a stethoscope analyzing x-rays and writing prescriptions.
Haha, not replacing doctors, but definitely helping them. One case study in Chapter 7 describes an LLM that analyzes medical literature and patient records to help doctors make more accurate diagnoses. It's not about replacing human expertise, but like enhancing it with the power of AI. Think of it as a super smart assistant that can process information way faster than any human.
Okay, that makes sense. It's like having a medical encyclopedia on call 247 that can, connect the dots in a way humans might miss. So we've talked about what LLMs are and how they're impacting different industries,
Yeah.
but how do these things actually work? Can we peek under the hood without getting too technical?
Sure, let's start with the basics. Chapter 3 explains neural networks, which are like the building blocks of LLMs. Think of them as like interconnected nodes that process information and learn from the data they're given. And this is where those attention mechanisms come into play.
Okay, attention mechanisms. That sounds kind of intense. So is this where the LLM like starts judging my grammar and sentence structure?
Haha, not exactly. Think of it this way. When you read a sentence, your brain naturally focuses on the most important words to get the meaning right. Well, attention mechanisms do the same thing for LLMs. They allow the model to weigh the importance of different words, which helps it understand context and relationships, even in complex text.
So it's like teaching the LLM to read between the lines. That's pretty cool.
Yeah.
But Chapter 5 mentions that training these LLMs requires massive data sets and serious computing power. Are we talking about feeding them like every book ever written?
You're not far off. Training these models requires a ton of data. The more data they learn from, the better they can understand and generate human language. Think of it like learning a new language. The more you immerse yourself, the better you become. And the scale of data needed is huge.
So we're talking mountains of data basically feeding these things the entire internet.
Right. That's a good way to put it. Training these models is a huge undertaking involving terabytes, even petabytes of data, and requires a ton of computational power. And it's still an evolving process.
That's mind-boggling. So we've got these LLMs trained on mountains of data. They can write poetry, diagnose diseases. What's next? Do we just sit back and let them take over the world?
Haha, not quite.
Right.
This is where things get even more interesting. Chapter 6 introduces fine-tuning, which is like taking a really smart student and giving them specialized training to become like a doctor, a lawyer, or even a poet. We can actually adapt these pre-trained LLMs for specific tasks or domains.
So it's like taking all that general knowledge and shaping it into a specialized skill set.
Exactly. And the applications are pretty amazing. Chapter 6 goes into some case studies. One example is a customer support chatbot that was fine-tuned to handle most inquiries without needing any human help. It learned to answer questions, process returns, provide order updates, all thanks to fine-tuning.
Wait, so companies are already using these things to automate customer service? No more waiting on hold forever. Yeah. That's a game changer.
Absolutely, and that's just one example. The possibilities with fine-tuning are pretty much endless. What stands out to you so far?
Honestly, it's the sheer scale of it all that blows my mind. The amount of data, the complexity of these models of potential applications, it's a lot to take in. But I'm definitely hooked. What else have we got?
Yeah, it is a lot, but it's really fascinating stuff. And it gets even more interesting when you look at like the advanced techniques that researchers are using to kind of push these LLMs even further.
Okay, hit me with some of that advanced LLM knowledge. What are they cooking up in the AI labs?
Well, one area that's really hot right now is pre-training. Chapter 8 goes into this. It's basically like giving the LLM, a head start before it goes to LLM college, like you said earlier. We're basically exposing it to huge amounts of data before we even start fine-tuning it for specific tasks.
So it's like a crash course in all things language, building a solid foundation before specializing.
Exactly. This pre-training helps the LLM like develop a broad understanding of language and, accumulate a ton of knowledge. And researchers are coming up with some pretty clever ways to make pre-training even more effective.
Okay, I'm intrigued. Tell me more about these clever pre-training techniques.
Well, one approach that's really taken off is called self-supervised learning. It's kind of like a giant game of fill in the blanks. The model is given a sentence with a missing word, and it has to predict what goes there, or it might be given two pieces of text and has to figure out if they're related or contradictory.
So the LLM is basically teaching itself by solving language puzzles.
Yeah, that's a great way to put it. By tackling these challenges, the LLM learns to recognize patterns in language, understand relationships between words, and basically teach itself how to use language effectively.
That's impressive. It's like learning by doing, but on a massive AI scale. What other tricks are they using to make LLMs even smarter?
Another cool technique is multitask learning, where we train the LLM on multiple objectives at the same time. It's like a multitasking master juggling different language skills at once.
So instead of just focusing on one skill, it's learning to translate. Write different kinds of creative content, answer your questions in an informative way, even generate different creative text formats all at the same time. Talk about a multi-talented AI.
Exactly. This helps the model become more versatile and adaptable. It can like switch between tasks more easily and even apply knowledge from one task to another.
That makes a lot of sense. The more skills you have, the more adaptable you are, right? But these models are huge. I can't even imagine the computing power needed to train them. Is there a way to make them more efficient without sacrificing their abilities?
That's a great question, and it's something researchers are actively working on. One technique that's looking promising is called knowledge distillation.
Okay, knowledge distillation. That sounds interesting. Is it like brewing some super concentrated LLM espresso?
Haha, that's a good analogy. Imagine you have a brilliant professor who wants to teach a student. Instead of teaching them everything from scratch, they could like distill their knowledge into more concise, easy to understand form. That's essentially what we do with knowledge distillation. We use a large, powerful LLM to train a smaller, more efficient student model.
So it's like creating a mini-me version of the original LLM, but with a smaller footprint.
Exactly. The student model learns to mimic the teacher's outputs, basically inheriting its knowledge, but with fewer parameters, which makes it more efficient to run.
That's pretty clever. It's like all the brains, but in a smaller package.
Yeah.
But I have another question about how these LLMs process information. We've talked about text, but can they really grasp long stretches of text? Like, could an LLM understand an entire research paper or a novel?
That's a great question. Traditional transformer architectures, while powerful, have limitations when it comes to handling really long sequences of text. They have a context window, which is basically a limit on how much information they can process at once. It's like having a short-term memory limit. But researchers have come up with some pretty ingenious solutions to overcome this.
Like giving them a bigger hard drive or something?
Well, not exactly a hard drive, but they've developed memory-augmented architectures that give LLMs a kind of working memory.
So it's like giving them a notepad to jot down important info as they're reading, so they can refer back to earlier parts of the text without forgetting.
Exactly. These memory mechanisms allow LLMs to store and retrieve information from earlier parts of the text, which helps them understand longer and more complex narratives.
That makes sense. If you're trying to understand a story, you need to remember what happened earlier. It's like having bookmarks in a book.
Yeah.
What are some ways researchers are implementing this working memory?
One promising approach is using recurrent memory modules. These modules can retain information from previous segments of text, allowing the LLM to maintain a sense of context even with long sequences. It's like having a built-in system for remembering important details.
So it's like highlighting key passages as you read so you can find them later.
Exactly. Another cool development is the use of external memory networks, or EMNs. These networks give LLMs access to external databases like a giant encyclopedia of knowledge. It's like having the internet at their fingertips.
Ooh, so they can fact check themselves as they go. No more making stuff up or hallucinating information.
Well, it's not foolproof, but EMNs definitely help LLMs produce more accurate and reliable responses. They're especially helpful for tasks like chatbots and customer service, where being factually correct is really important.
Okay, so we've covered a lot here, from pre-training to memory augmentation. It's amazing how researchers are constantly finding ways to make LLMs more powerful and versatile. But I'm also curious about how we take all this potential and turn it into real-world applications. What are some of the newest techniques for fine-tuning these LLMs for specific tasks?
That's a great question, and it's an area that's evolving super fast. One of the most promising techniques is using adapters.
Adapters, like those things you use to plug different devices into an outlet. Are we talking about plugging an LLM into like a medical database or a legal library?
You got it. But in the LLM world, adapters are small, trainable modules that we insert into the model's architecture. They allow us to fine-tune the LLM for specific tasks without changing its core parameters. It's a really efficient way to adapt LLMs without having to retrain the whole thing.
So instead of rewiring the whole LLM's brain, we're just adding a specialized tool to its toolbox. That's pretty neat. What else are they up to when it comes to fine-tuning?
Another crucial thing is prompt engineering, which is all about designing effective prompts that get the responses we want from the LLM. It's like writing the perfect instructions to get the best results.
So it's not just about what data you feed the LLM, but how you ask it to process that data.
Precisely. It's about understanding how LLMs interpret instructions and crafting prompts that guide their behavior. And there are some really clever techniques being used in prompt engineering.
Okay, I'm all ears. Spill the prompt engineering secrets. What are some things they're experimenting with?
Well, one approach is using prompt templates, which are pre-written prompts with placeholders for dynamic input. It's like having a fill-in-the-blank script that you can adapt to different situations.
So instead of writing a new prompt every time, you can reuse these templates and just plug in the specific details. That sounds like a huge time saver.
It is, and it helps make the LLM's responses more consistent and reliable. But prompts are only one piece of the puzzle. What about context retention? Can LLMs remember past conversations to give more relevant responses? That seems crucial for things like chatbots. Absolutely. Context retention is super important for making those interactions feel natural and seamless. Developers are using techniques like prompt chaining, where each prompt builds on the previous one so the conversation flows naturally. It's like having a back and forth where both sides remember what was said before.
So it's not just individual prompts, but a whole chain of prompts that guides the conversation. That's impressive.
Hmm.
But all this raises a question for me. We've talked about all these amazing capabilities, but how do we make sure they're aligned with our values? Can we control their behavior, or are we just letting them do whatever they want? I've seen enough sci-fi movies to be a little wary of AI going rogue.
I get it. It's really important that we develop LLMs responsibly and make sure they're aligned with human values, and researchers are definitely working on this.
Okay, that's reassuring. So what are some strategies for keeping these LLMs in check and making sure they're working for us, not against us? What's the secret to ethical AI?
One technique that's showing promise is reinforcement learning from human feedback, or RLHF. It's a mouthful, but the idea is pretty simple.
Okay, break it down for me. How does RLHF work?
It's basically a system where we get feedback from humans on the LLM's responses. We use that feedback to train the model to give outputs that align with what humans prefer. It's like giving the LLM a performance review based on how well it's doing.
So it's a constant learning process where the LLM gets better and better at understanding what we want. That makes sense. But I'm also curious about the big picture. Where are LLMs headed in the future? What's next for this rapidly changing field?
The future of LLMs is super exciting. We're just scratching the surface. One area that's really taking off is multimodal capabilities.
Multimodal. Does that mean LLMs can do more than just text? Can they see, hear, and understand the world around them?
Exactly. We're talking about LLMs that can process and generate stuff based on different types of input like text, images, and audio.
Whoa, that opens up a whole new world of possibilities. Imagine an LLM that can analyze a medical image and give a diagnosis or write a screenplay from a series of photos. That's next-level AI.
It is, and it's already starting to happen. Researchers are developing visual language models, or VLMs, that can handle both text and images. It's like giving them eyes to see the world along with their ability to understand language.
So instead of just reading about the world, they can actually see it and understand it. That's mind-blowing. What other multimodal magic are we working on?
Another exciting area is fusion-based models, which can handle even more than two modalities at the same time. Imagine an LLM that can analyze a video using audio cues, visuals, and the script to summarize it or even detect inappropriate content. It's like a super-powered AI assistant that understands all kinds of media.
Okay, my brain is officially overloaded with LLM awesomeness. It sounds like we're on the edge of a whole new era in AI, where these models can interact with the world in a much richer way. But all this incredible tech must come with challenges, right? I mean, it can't all be smooth sailing.
Of course, there are challenges. Deploying and scaling these LLM applications in the real world comes with its own set of hurdles. It's one thing to develop a powerful LLM in a lab, but making it work smoothly in real-time applications is a whole other story.
So it's like the difference between building a race car and actually winning a race. It's not just about speed, it's about handling control reliability. What are some of the biggest challenges in deploying these LLMs in real-world situations?
Oh yeah, for sure. There are some really cool real-world case studies that show just how powerful and useful LLMs can be. Like, companies are using them to automate customer support review legal documents, help with medical diagnoses, give personalized content recommendations, even spot financial fraud.
That's incredible. It sounds like they're already making a difference in people's lives. Can you give us some specific examples? I'd love to hear about some of these LLM success stories.
Definitely. Let's start with something that's probably familiar to most of us: online shopping. There was this e-commerce platform with, millions of customers, and they wanted to provide better customer support, more efficient and personalized.
I can totally relate. I've spent way too much time on those contact us pages myself.
Right. Well, this company decided to use an LLM to tackle this. So they took a model kind of like GPT-3 and trained it on a massive data set of their past customer interactions, like product catalogs, shipping policies, FAQs, everything the LLM would need to be a customer service expert.
So they created like a digital customer service guru.
Exactly. And to make it even easier to use, they integrated it into a conversational AI platform. So instead of clicking through menus or waiting on hold, customers could just chat with the system like they would with a real person.
That's pretty cool.
Yeah.
But did it actually work? Were customers happy with this AI customer service agent?
The results were really impressive. The system could handle something like 70% of customer inquiries all on its own without any human help. It could answer questions about products, process returns, give order updates, all super fast.
That's a huge win for the company, A&D, the customers. No more endless hold music or confusing phone menus. What other LLM magic have we got?
Okay, let's shift gears from online shopping to the world of law. Imagine a law firm that specializes in mergers and acquisitions. They're dealing with tons of contracts and legal agreements, the kind of stuff that can make your head spin.
Definitely not light reading. So how did LLMs help in this case? Did they replace the lawyers completely?
Not replace them, but definitely made their lives easier. The firm was having a big problem with manual document review. It was taking forever, costing a lot of money, and was prone to human error. So they took an LLM like BERT and trained it on a massive data set of legal documents.
So they created an AI lawyer.
Haha, you could say that. The LLM was trained to find key clauses, assess risks, and categorize documents. It could even flag potential problems that human reviewers might miss.
Wow, that's amazing. It's like having a super-powered legal assistant that never gets tired. How did they measure the success of this AI lawyer?
Well, besides saving a ton of time, they found that the LLM was much more accurate and consistent. It could spot potential risks that human lawyers might overlook, which led to better decision-making, and could even prevent expensive legal battles in the future.
That's a big deal in the world of corporate law. It seems like LLMs are having a real impact in some pretty important areas.
Yeah, absolutely. And it's not just law and e-commerce. Let's talk about healthcare. Imagine a busy hospital, a radiology department just swamped with medical images like X-rays, MRIs, CT scans, all needing to be analyzed quickly and accurately.
That sounds intense. How did LLMs help in this situation?
The challenge was to analyze all those images and reports and connect them with clinical findings to make diagnoses faster and more accurately. It's a lot for radiologists to handle, especially with their workload constantly increasing.
So where do the LLMs come in?
They took an LLM and trained it on a huge amount of medical texts and radiology reports. This LLM working with image recognition algorithms could analyze images, find potential issues, and even suggest possible diagnoses to the radiologists.
So it's like an AI consultant working with the doctors.
Exactly. The system could analyze images much faster than humans and often notice subtle things that humans might miss. It wasn't replacing the radiologists, but it helped them make accurate diagnoses much faster.
That's a huge improvement for patient care. Faster diagnoses mean faster treatment and hopefully better outcomes.
Right. And it's not just these three fields. We're seeing LLMs being used to personalize recommendations on streaming services, detect financial fraud, write news articles, provide financial advice, streamline legal work, and even make supply chains more efficient.
Wow, that's amazing. It shows just how versatile and adaptable LLMs are.
It does. And we're really just getting started. The field is moving so fast with new discoveries and applications all the time.
So what does the future hold for LLMs? What can we expect to see in the next few years?
We can expect even more advanced and specialized LLMs that can handle even more complex tasks. We'll see improvements in few-shot learning so LLMs can learn new things with less training data. And multimodal capabilities will keep evolving so they can interact with the world in more ways.
So basically, LLMs are going to get even smarter, faster, and more versatile.
Exactly. We might even see LLMs that can design experiments, compose music, or even create whole new forms of art. The possibilities are pretty mind-blowing.
That's an exciting future. It's been incredible exploring the world of LLMs with you. We've learned about their potential and a real impact they're already having, and it feels like we're just at the beginning of this LLM revolution.
It's been great diving deep into this with you.
Thanks for being our expert. And to everyone listening out there, keep exploring, keep learning, and stay curious about AI. Who knows what amazing LLM-powered innovations are coming next? Until next time, keep diving deep.